Okay, so most standardized tests are adjusted to be normally distributed. And any small group of tests should not be forced to be normally distributed. A lot of times when people used to talk about scaling test scores or grading on a curve, what that meant was forcing the test scores to be normally distributed. That is, if we look back at my picture here, based on the average test score and the standard deviation, we force 95% of the grades to be within 2 standard deviations, or to be within 1 standard deviation of the mean. And the belief used to be that only this upper 2.5% should get A's. And the beliefs on grades and grade distributions have changed a lot over the last 5, 10, 20 years. And so that really isn't a trend anymore. But large scale tests often are forced to be normally distributed, or they just happen to end up that way anyway. So I have a little bit of data here about, let's see, smarter balanced test scores about the Common Core standards for different areas. And I'm just going to focus on the mathematics ones. So I went out to the Department of Education, Oregon Department of Education website. I pulled up this document right here, and I will share that in the chat. And the YouTube video. So if you want a copy of that document. And then I wanted to get a better understanding of these cutoff scores they have for the different levels. And so I had to head over to the Smarter Balanced website, which the Department of Education links to. And I can't quite remember the relationship between Smarter Balanced and Department of Education. My recollection is it's a for-profit company that was hired by many states to help with the testing of all of the students, which is no small task, right? To give the same test to every single student and then keep track of all that data, it's a big deal. So often that's kind of contracted out. So here they have a little bit more detail. This is for 11th grade. And here I have the mathematics scores here, and they're broken down into a few categories below. So we have the categories: concepts and procedures, problem solving, modeling, data analysis, communicating, reasoning, and the overall score. So I'm just going to look at the overall score here and just kind of compare these two different documents together here. And they should agree, but I just pulled them off the website, so we'll see. And then we'll think about them in terms of mean and standard deviation and percentiles. So I gotta screenshot some of this stuff to summarize it better. Oh, there we go. So let's see, I want this section here. And sometimes finding all of this information is hard. I spent about, I don't know, half an hour, 45 minutes searching for the right data, and I couldn't find everything I wanted. Go back and look later. This bit of information, hopefully that matches the information from the Smarter Balanced people. And oh, did I forget to share this one? I did. Let me share this document too. Copy of it. So this was just a sample report. And somewhere at home, I have a whole bunch of these from my kids in school. And I want just this part. And let's see, do these numbers match up? I'm missing a little bit. That was level 2, 3, and 4. Let's see. It's this one, 2, 3, and 4. All right, good enough. What do we have have here. So this must be the cutoff for level 3 mathematics, 2,628. Okay, so that 2,628 would be this mark right here. So on a number line, 2,628. And my recollection is that that is the edge of what's considered grade level, like the grade level average. So I'm going to take that to be my mean, X bar. And then this number right here, let's take it to be, so here they say the edge is 2,717, 2,718. Let's call this the upper one, 2,718. And down here, that would be 2,543. All right, so what do these numbers give us? Let's check my calculator. Calculator, please. $2,718 minus 2,628 is 90. So this range right here is a span of 90. We go the other way. 2,543. We get, ooh, I did not type that right. Oh, wrong number. 268 minus 2,543. 85, close but not exactly the same. Interesting. So the question is, if we were trying to think about this related to a normal distribution, would say out here represent maybe the and over here our middle 95% that they expect to have most students in that range. What do you guys think? I didn't find enough documentation to establish that. Now I'm just guessing. And the reason I'm guessing is I want to establish for these scores, what do they think the mean is and what do they think the standard deviation is? All right, so I have no comments, I don't hear anything, so I'm assuming you guys don't know any more than I do about this, so that's okay. We're just gonna make some guesses then. So it feels to me like this should be the middle. The scale's designed to have that to be about a middle. So I'm thinking that's average grade level score. So the mean for 11th graders, I'm going to assume is 2,628. If I expect most of the students to be in this range right here, I'm going to take most to be 95%, given our 95% rule from before, so that whatever this number is right here would be 2 standard deviations below average. So z equals 2, and this number would be 2 standard deviations above average. Sorry, this would be z equals -2, and this would be z equals +2. And then this right here would be a z-score of 1 and a z-score of -1. So then the standard deviation is around 85 or 90. And so I think I'm just going to pick 90 because it's easier to work with. So I'm going to guess then that the standard deviation here is 90. So then if I take another 90 above here, then this end of level 4 here, we would claim that is 2,808. And if we take 90 away from that side right there, where would we end up? We would end up at 2,453, is that right? Let's double check that. Right. Yeah. Okay, so that sets up our ideas about normal distribution, standard deviation of 90. Okay, so let's suppose I have an 11th grader, and we have this 11th grade student has a math score of 2,500. What kinds of things can we tell the parent and the student about their score? So I'm going to write these down, put them on a cleaner window. And these numbers are a little bit rough, exactly 90 apart, but they're close enough. And we have a student who has a score of 2,500. What based on this information, what can we tell parents about it? So to think about it, I'm going to draw myself a normal distribution, assuming that grades like this are normally distributed. And so right in the middle of this distribution here, I would expect to see a score of 2,628. Right? That was the mean, X bar. As far as a z-score goes, right, that's a z-score of 0. And then looking one standard deviation on each side, here and here, we were given 2,718 and 2,543. Looking two standard deviations on each side, here and here, we have 2,453, and then over here we had 2,808. And then we now have a student to deal with, which is right in between here. X equals 2,500 is that student's score. So what I want to do is I want to try and estimate here what percent of students scored lower than this student. What percent of students scored higher than this student, that region over there, to kind of give the student and the parent an idea about what's going on here. And in order to do that, I just need to make a few assumptions, which I started making on the previous page. So the first assumption I'm making here is the math test scores are normally distributed. Do I know they are? The answer is no, I'm just guessing. Based on research with SATs and they're designed to be normally distributed, but I'm not as sure about smarter balance testing. Two, the other thing here I'm assuming is that the mean is that 2,628 and that the standard deviation here is 90. Okay, so those are other assumptions I had to make here, which seem reasonable given the sample data that they provided here. To find that percentile here, I just need a normal distribution calculator, and there is one available at StatKey. That link with everybody again, or you could just search for it. We looked at this a little bit last class. So there's the link. If you are on YouTube, that link should be in the description. And what we're going to do is jump down to, because we don't have all of the data, so I can't use some of these other tools from StatKey. I have to use the theoretical distribution, and I'm assuming it's a normal distribution. So they give me this general picture of the symmetric bell-shaped normal distribution. I just need to edit it for my mean and standard deviation. So again, from the StatKey homepage, I'm jumping over to the normal theoretical. So just in case you're having trouble getting there, I'll put that link in there too. I'll call this a normal calculator. So there's a chat too. And so usually the first thing I do is, if I don't want to mess with z-scores, which is the default, z-scores have a mean of 0 and standard deviation 1. I put in my mean. So 2,628 is where I was putting my center. And I'm going with a standard deviation of about 90. So here I can see that score of 2,500. And I want to know what percent is left. What's the left tail? So then I just click left tail, and I put my number at the bottom, 2,500. All right, so what I can see here is I get this 0.077. So that's the percent as a decimal. Got the notes. So this percent right here was given as a decimal first, 0.077, which would be 7.7%. So this student is not quite in the 8th percentile. So they only scored better than 7.7% of other students. So at first glance, we might look at, oh, they got a 2,500, average is 60 to 2,600. That's not too bad. But given that the average spread is 90, that's actually not so hot, right? So what do I know? A score of 2,500 means that 7.7%, we could round that to 8 if we wanted, enough, means that 8% of students scored worse than this student. 8% of other students scored lower. We could put it in a more positive light that this person scored higher than 8% of the other students, right? That would mean the same thing. Score 2,500 is higher than 8% of others. All right, doesn't sound much better. What about going the other way? Well, if there's 7.7% below, then there should be what, 92.3% above? And we can easily double check that by just asking the calculator instead of a left tail, say, hey, give me a right tail. And then we just put our number at the bottom, 100, and I get 92.3% scored higher. Or this student scored lower than 92.3% of other students. So I think we probably need to do a little bit to help the student improve their math skills. Extra tutoring, more help at home, less distractions with the cell phone or video games, whatever the problem may be. What percentile would this score be? So we have the score X equals 2,500. What percentile is that? So if we round that 7.7% up to 8%, this would be the 8th percentile, P8. What does the 8th percentile mean? Well, it really means all of these things here. It's usually stated in that green wave right there, being the 8th percentile. So assuming the scores are normally distributed, if we know the mean and the standard deviation, then we can take any score and turn it into a percentile. Now, to do that, we need a special calculator to do it. Spreadsheets can do it. It's a little bit of work to do it on a spreadsheet. I'm not going to go over that here as much as I love spreadsheets, just because this particular tool makes it so easy. We just type in the mean, the standard deviation, put the score we want, and then we can look at the percent above or this percent below. And remember, percentile is definitely the left tail. So percentile means what percent of the others are at or below that point. That's the idea of percentile. And percentiles are pretty common when talking about standardized test scores. What percent did you do better than? All right, so that's all but one topic, and I think we're going to actually skip the last topic. The last topic was the idea of simulations using spinners, dice, or random number generators to try and mimic some situation we're trying to understand. There was a pretty good example in the book of this, but we would need a whole nother class period to do it, and I would like to move on to geometry next. So we're going to stop here. The last couple things for you to do this week, week 3 here. So we have the homework. There's some pre-recorded videos about the stuff we've been doing the last 2 days here. And then this activity is like the activity we just talked about with that, the Common Core Smarter Balanced test score. In this situation, we have information about a student's reading level, how many words per minute they read and how many words per minute they're expected to read at this age. And so you're going to do something similar to what I just talked about there. If I know a little bit about the center and spread of the reading scores, and I know a particular student's reading score, can I talk about how they rank among other students? And so this is going to be you getting some data, kind of like that report go I had when you become teachers. Is that this one? Oh, that one. This one? Yeah. You're going to get these printouts like this, and you're going to have to go over them with parents and try and help parents understand, what are they talking about here? What does it matter that my kid's here or here or here? So this is kind of to help you think about analyzing these kinds of reports and helping parents understand, are things going well or not well?